Hey guys, welcome to lesson 5, and we are going to talk about factoring trinomials. So it's this finger right here, the middle finger. And so I want you to talk about perfect square trinomials in the previous video. So these are just those old school factoring trinomials that you've had probably since Algebra 1. So what method do you use? Like there's a zillion methods out there. There's the ARF method, there's the AC method. Just whatever you feel most comfortable with, just go with it. They're all doing the same thing, so it doesn't really matter which method you use. One might be easier to somebody else that's really difficult to use, so it's just whatever you feel most comfortable with. Okay, I will do the AC method. I think that I see that the most in students, but feel free to do whatever you want. So if we're going to factor this one, what I would do is I would start off with um, multiplying the 2 and the 3 together. What we're doing is we're going to split apart this. So that's why this. I don't care about x squared. Don't worry about that. I'm going to split apart this middle term. So right now I have 6x, and I need to make it -5. So what are two factors of 6, so factors for multiplication, that subtract, so that's going to tell me if I'm going to add or subtract terms. So subtract, get -5. So I have -6x plus 1x, and that -6 times 1 is going to give me that 6. And if I subtract these, that is going to give me -1 minus 6 is going to give me that -5. So also, if you want to look at, I don't know, I said that kind of weird, but if you want to look at this, you're going to have other way. Okay, so then it's going to become a fact by grouping. So I'm going to take the first term and I'm going to split apart the -5x into -6 plus 1, and then it's last. So notice that these terms haven't changed at all. I just made this middle -5x just look different. Okay, so now we're just going to fall back on that factor by grouping. So they have the 2x in common, and one with x minus 3. We have to get an x minus 3 over here. So I'm going to ask what, and I have to pull out something. What do I pull out to make it look like there? Pull out +1. If everything's there except for the sign, so my answer is 3x plus 1 times x minus 3. This is a factor that they have in common. Just factor that out. This is my final answer. Please take the time, if you're not sure if you did them right or not, go ahead and multiply these two together. So like 2x squared plus 1x minus 6x minus 50. And they should always give you, like if you do like FOIL method or whatever, you always should match these 4 pieces. So if something not right, you probably factored wrong along the way. Okay, so for this one, let's go back to this GCF. That is always important. So even though we have a trinomial, we're always going to do that first. So before I do anything, I'm going to factor out a 5. And then factor out this one. So go ahead and try to do that. Okay, so my final answer is 5 times, and then 4x minus 3, and then what they have in common is the x plus 1. And again, notice I have a minus here, so I have different signs here that I'm subtracting. Okay, go ahead and try the next one. Okay, and so you should have gotten 6m plus 5 times m plus 2. Notice this means the same sign, and I'm going to add these two together. So 12 plus 5 is 17 to get that middle one. Okay, so go ahead and try this one. Okay, be really careful on this one. I purposely put this one in because a lot of people will write this. And notice that this tells me everything. So this tells me that it has to be the same sign. And then you look over here and they're both minus. And we're also adding them together. So 2 plus 3 is 5. This 6 minus 1 is 5, but it doesn't have the same sign. So if I were to multiply the negative 6 times 1, that's going to give me a minus 6 instead of a plus 6. So I know that this one is not correct, but this one is. So that's a common mistake on a test. Um, so go ahead and try this last one before we kind of switch gears. Okay, so this one is pretty straightforward. They're going to be the same sign, and we're going to add them together to get 11. So negative 9 plus negative 2 is negative 11. Okay, so these last two deal with variables. So think about what you can factor out. So it's easy to see that you can factor out a 5, but can you factor out a d to a certain power? So think about your exponent rules, and we can actually um, pull out a d to the x power. That's what they have in common. So think about this. This is 5x, and this is 1x. So if we pull out here, if we pull out a 5d to the x power, then I'm going to have d to the 4x power left because I already pulled out 1x here. Okay, and so now I don't have any d to any power left over here. So if I take 5 out of 45, that's going to be a 9. Hopefully you're going to see that it's this difference of squares, this binomial, and so we can actually break that up as well. So I have 5 to the x power, and then I'm going to break these up into two different binomials. So if I took the square root of this, remember square root is dividing it by 2, the exponent by 2. So it's going to be b to the 2x power for both of them. And then the square root of 9 is 3. And these break up into conjugates. One's minus and one's plus. And that's my answer. Okay, let's go to this one. So this one, notice that I just want you to see something. There's different ways of teaching this, but notice that this and this, they are not doubles of each other. So I want to point out what I'm talking about here. So if I have x to the first and then go to x squares, those are doubles of each other. Same thing, a to the first to a square. It's doubled going, the exponent is doubled going from the middle term to the first term. So that's the first thing that's jumping out at me here. Another thing that is jumping out at me is that they all have an a in common. So I think I want to take that out first and see what happens. So if I take out 1a, then I'm going to subtract the 1 from each of them. So I have a to the 2t power, and then plus 4a to the t power plus 1, because I took everything out of here. Okay, so now this, going from here to here, that is doubled. So it is the same thing. This is like a quadratic in disguise. So instead of when I factor, instead of saying like, so here we had a squared, so we factored it into a and a. Here we had x squared, we factored it into x and x. Here we have a to the 2t, so we're going to factor it in to a to the t power, a to the t power. So I don't know about my coefficient yet. I haven't thought that far ahead yet. But notice it's always going to be this middle term. Whatever that middle term is, that is what your factors down here are going to be. Okay, so I'm going to look at this. This like might be hurting your head right now. So I just want you to look at it as like 4x squared plus 4x plus 1. And go ahead and factor that just as is, but notice instead of the x, I'm just going to say a to the t power. So this ends up being 2x and 2x. This is a perfect square binomial. So instead of saying 2x plus 1, I'm going to say 2a to the t power plus 1, 2a to the t power plus 1. So I'll just clean this up again. So this is 2a to the t power plus 1 squared, and that is my final answer. So we're going to follow this. Notice like when I break this up, it's just going to be x to the third, x to the third, and then whatever it is. This one, as long as it's doubled, so 3 to 6, that's doubled, 2 to 4, that's doubled, 2 to 3, that's not doubled. So we'll deal with that in a second. So what I want you to do is go through these first two and figure out how you would solve those. Okay, so this one is actually the exact same problem that we had earlier. So instead of just saying x squared minus 5x plus 6, everything is going to be like when I factor it, it's going to be x to the third and x to the third instead of just x something. So anyway, so in your brain, you're going to be factoring this, but in reality, when you get down, instead of saying x minus 2, I'm going to say x to the third minus 2. Same thing here. Instead of saying s minus 4, I'm going to say s squared minus 4 and s squared minus 9. And then we could break these up more. Okay, this one is not doubled, so it's waving a red flag. So I'm going to factor out a c first, and it should make it better, and it does. So go ahead. So see if you can do these next three, and we'll do that one together. Okay, so this is kind of how I do this portion when I do the AC method, and I end up with this. This should seem familiar because we've had a very similar problem, except it was just 2x squared minus 5x minus 3. These are very similar to each other, so notice just the exponents were different, but it made our results very different. So here we had the sum of cubes, which ended up like that. We had to factor it more. And here we have the difference of squares, which ended up like that. Okay, so for this last one, notice that this is doubled. So I'm going to factor it into x to the y and then x to the y. And so I have the same, so it's negative 72. So it's going to be a negative 9 plus 8, and that's it. So don't let this these variables, the weird ones, kind of flip you out. It's just fine. And we are done.